My name is Loretta Jones. I'm the VP of Growth here at Acceldata. And thanks so much for taking the time to attend our webinar, which is kind of how data observability can reduce your total cost of ownership for Hadoop. We're going to offer strategy and support for Hadoop and go into a few slides just to give you some context about Acceldata and about our solution and support services for Hadoop. And then we will actually go into a demo so that you can actually see the product, get a real life view of the product. So without further ado, let me introduce Mark Burnett. He is the Director of Product Marketing. He's going to take you through the slides. And then Shubham Sharma is our solutions consultant, and he is our resident subject matter expert on Hadoop. So Mark, take it away.
Thanks, Loretta. Yeah, so as you described on the agenda, we'll provide a brief introduction to Acceldata and its core mission, which is to provide data observability for the enterprise. Then we'll focus in on Hadoop specifically, some of its challenges and common strategies to address them. We'll highlight how Acceldata can help organizations with Hadoop, with journeys to the cloud, open source adoption, and other types of initiatives. And we'll explain our data observability platform and support offerings for Hadoop. We'll provide a demonstration of some key parts of our platform, and we'll save a little time at the end for some Q&A. So more and more often, data is being viewed as a product, an asset that's packaged for internal and external consumption. And furthermore, both traditional and new products are becoming smarter with capabilities and insights driven by data analytics, making them a type of data product as well. In both cases, data products are becoming increasingly critical to the success of business operations. Yet data operations at the enterprise level can be quite complex, and there are many blind spots, potential points of failure, and inefficiencies that introduce excess risk and excess cost. And in a nutshell, data teams lack visibility. So data observability is a concept that's emerged to address this lack of visibility. Observability is not merely about more monitoring. It's about applying analytics to be able to observe insights into data quality, reliability, performance, efficiency, and other factors. And Gartner's recognize that data observability is now essential for enterprise data success. They describe it in 4 parts: observing the data infrastructure that processes and moves the data itself that runs on top of that infrastructure, the data pipelines that are the workflows that orchestrate data and processes, and the associated user behavior and consumption patterns. Together, this gives data teams a multi-layered 360-degree view of data operations. At Acceldata, enterprise data observability is our primary focus, and our mission is to enable enterprises to build and operate great data products. Our company's grown at a rapid pace due to the high demand for data observability, the capabilities we've brought to the market with our platform, and the expertise and support that we provide to our customers. Note, our founders and many of our engineers came from Hortonworks and Cloudera. We literally created many parts of the Hadoop ecosystem in our previous careers. So while we do support many different technologies, in this presentation, we'll focus on data observability and support for Hadoop. Now, Hadoop's been around for over a decade, and yet despite that longevity, it's still quite complex and cumbersome, expensive to operate. The Hadoop ecosystem has many components. There's monitoring for some aspects, but there are still many other blind spots. And this creates excess management overhead in terms of support and maintenance. Hadoop's complexity requires highly skilled talent. And this talent is increasingly in short supply as engineers tend to shift toward newer technologies lest they fall behind. Many organizations will deploy excess resources or over-provision resources as a safety measure to ensure service level objectives are met, or simply because it's not always clear what configuration is the most efficient. So this combination of excess deployment, inefficiency, high maintenance, and scarce talent lead to high overall cost, particularly at scale. So what are organizations doing about this? We frequently see 3 high-level approaches. Stick with the Cloudera, migrate to alternatives such as Databricks, or Snowflake, or others, or take a do-it-yourself approach with open source technologies, such as the Hortonworks data platform or Apache. Now, each of these approaches has some drawbacks in terms of risk, timing, cost, and talent, and I'll describe these challenges and how Acceldata can help. So let's start with Cloudera. Cloudera is ending support for the legacy HDP and CDH Hadoop distros and moving all customers to their CDP platform. This migration can introduce significant risk depending on the customer's environment, as there are many differences between the distros and a number of deprecated technologies. Cloudera is no doubt working to accommodate customers' schedule to some degree, but it's clear customers will not simply be able to continue running their legacy platforms like they might do with their mainframe systems. Many organizations cite that in addition to the cost of migration, which can be significant, the cost of CDP licenses can be higher as well. Finally, Cloudera provides a cloud offering which will help ease some of the maintenance and administration. However, the system is still quite complex and requires advanced skills. Next, I'll describe migration to some alternatives. Like Cloudera, moving to Databricks, Snowflake, or other technologies will require migration, which introduces risk. Cloud architectures are fundamentally different. So, for example, it's unlikely that HDFS will make sense in the cloud. With support ending for CDP and HDP, customers will have to act fast. Expedited migrations introduce more risk and cost. An alternative is to stick with Cloudera and upgrade to CDP, and then maybe upgrade to an alternative on a more convenient schedule. But this means 2 migrations, potentially double the risk and double the cost. And from a talent perspective, you'll need to ramp up on new skills, on the new technology, and this may involve retraining, hiring, or both. Now, some are choosing to go the open source route. And if you happen to be running the Hortonworks data platform or CDH Express, you may be able to continue using your existing environment and avoid the risk of a migration. That said, giving up support can add significant risk if incidents arise. Now, support for CDH and HDP is ending soon, which adds pressure from a timing perspective. Now, clearly, this can lower your costs and provide more flexibility over configuration, versions, and other factors. However, more support staff may be required to manage it solo. You may need deeper expertise to manage without support. Additional talent may be needed for 24/7 support, and you may want some redundancy in case there's attrition. Now, Acceldata provides a data observability platform and service offerings specifically for Hadoop to help overcome all of these challenges that I've reviewed regarding, and also allows you to have flexibility around your roadmap. When it comes to risk, we provide 24/7 support for your legacy platforms that Cloudera is dropping. You can avoid the risk of migration and enjoy the benefits of open source without sacrificing support. Plus, our data observability platform provides insights to improve reliability, performance, quality, and with faster root cause analysis and insights to predict and prevent issues. And we can also help you compare and measure both performance and quality if you're doing a migration. Now, from a timing perspective, with continued support for legacy Hadoop, you can now pursue your roadmap on your schedule, choosing to either stick with your existing environment or migrate to new technologies on your timetable. We provide superior SLAs at a fraction of the cost. Plus, data observability insights improve efficiency to significantly reduce infrastructure costs. From a talent perspective, you can continue to leverage your existing skill sets that you have on your current platform. Data observability significantly improves engineering productivity, and you have access to Acceldata's exceptional pool of talent for support and service offerings. So next, let's take a closer look at our platform and support offerings. We have 4 basic service offerings. The first is data observability platform support, which provides support for our products and platform. Next, we offer Hadoop support, which provides support for the Hadoop platform itself, potentially as an alternative to Cloudera or to provide additional support on Apache and so forth. We can even provide Hadoop administration support. So this is in the form of a named site reliability engineer, and that can be on either a part-time or full-time basis. And we provide project-based support, and this can assist with upgrades, migrations, and other kind of one-time events on a per-project basis. Our data observability platform provides insights into infrastructure, platform services, data processing, and the data itself. It's the only platform that really covers all of this breadth. I'll demonstrate, or Shubham will demonstrate some of these capabilities shortly. The platform on its own allows customers to achieve greater reliability and efficiency for Hadoop environments. And for those customers that also purchase additional support for Hadoop from Acceldata, this platform is what enables us to provide superior SLAs and at lower cost. Here's a quick example of some of the results one of our key customers has achieved with our data observability platform support and services. PhonePe is the #1 payment platform in India, surpassing $1 trillion in transactions on an annual basis. Now, when we first engaged with them, they were experiencing performance issues, which were preventing them from being able to scale. Now, 60% of their experienced engineers' time was spent firefighting and operational issues. Now, this was limiting the company's overall ability to grow. Now, since implementing Acceldata, they've been able to achieve 0 unplanned outages or SEV1 incidents for over 18 months and counting. They've been able to scale their infrastructure by 13x while meeting their SLAs, and they've saved over $5 million a year in licensing costs. So next, let's explore the data observability platform in a bit more detail. I'll go ahead and pass it over to my colleague Shubham to give you a bit.
Hey, thanks, Mark. Let me share my screen. I hope my screen is visible.
Looks good, Shubham. Thanks.
Okay, great. Hey, thanks everyone. Welcome again to the webinar. And here in this demo, so we'll do a walkthrough on the Pulse. That is a product marked and reputed for observability on a Hadoop platform that helps you understand and provide you insights on the services, components that you're running, and improving the performance of your modern data application. As you can see on the screen, on the main landing page, so we try to highlight here the complete cluster statistics, the overview, how is it being utilized, what is the current threshold, what is current storage IO bytes, HDFS utilization. That is the key indicators in order to know how the health of the system looks like. On the below, you will be able to see the liveliness of the services that is enabled from the Hadoop cluster. That helps you to kind of let you know that everything is in green, everything is going good or not. And over the period of time, you'll be able to kind of view that on all the dashboards and pages, we have this time picker, which helps you to understand that if you go back in time, or if you want to check anything what is happening or going wrong in the system, you can quickly check and select the dates or do an analysis over the period of time from just this time values here. You'll also be able to see that on this critical incidents and the incidents that is raised in last 24 hours and how many of them are currently actively raised. And below, you'll be able to kind of visualize the workload types, how many types of workloads are running in the system, what kind of recommendations are being generated for these application types as well. So from this, on the left-hand side, you'll be able to view that which is the active cluster. So yes, we do support multiple clusters being supported through single instance, through single Pulse UI. So if you're wondering, like you have multiple production clusters and you need to hop onto multiple pages or dashboards in order to look for same metrics or different views. So here we try to provide a centralized view to look into things. On the left-hand side, you'll be able to see the components list, as well as some of our own tools and features that we enable to increase the proactive observability, making things a little bit better in terms of giving you the insights on the infra level on which your apps are being hosted. Also on the database explorer, how the logs are being collected from multiple services, and more alerts and actions that we'll go through in this session. So from the storage front, the first focus that everyone kind of knows and wants to see that how's your storage services, that is majorly HDFS that we are monitoring here and we are showcasing here how it is performing. So we do have these service dashboards, inbuilt service dashboard that tells us the liveliness of the services. So at the system runtime level, the CPU, memory, tele events that comes in from the OS, or the utilization at the heap memory level, how things are looking like. So you'll get to see all those metrics in a time series based here. That helps you kind of create any kind of comparisons or any kind of a check that you want to go back in time and do that. So in case of any kind of an outages, you may want to check what was the heap utilization at that moment, or how much capacity is currently being utilized, or how is the things looking from start to the end of the month. So in case you're doing some kind of an ingestion or you're planning some kind of a purging or archiving activity, so you'll be able to view these trends dynamically here. You also get to see all better detailed information around the RPC metrics, the total block count summary, and also all the data nodes that is being hosted on the system, whether they are balanced or not, or there is a case to run the balancer over there. So along with this, we also do a more high-level analytics in terms of aggregating some of these details and doing more of a deep dive into how the storage is distributed in the system. So as you can see from these reportings, you will be able to know that which user is consuming the highest footprint, classification of the files that is stored on the HDFS itself. So what kind of files are we storing? How is the file size looks like? Because small files in an HDFS is a very critical issue. And it's also a very popular thing that everyone wants to reduce as much small files as they can create in system, or they can concatenate, or they can find a way that they can easily view from a simple dashboard or some simple widget. They can click on it and they'll be able to see where such small files are there in the system. So with just simple click, you'll be able to come to that specific filter and you'll be able to see where are such most small files are located in your file, in your HDFS. Similarly, if you go below, you'll be able to see which user is or holding of these number of small files, or who is the culprit who is storing such small files in a specific directory. So you will always get a scope of optimization of reducing such small files in the system, as well as you also get to see where you can save some cost. So in some of the cases, when the HDFS utilization reaches to 80, 90% kind of a way, and you figure out that how many more number of nodes needs to be added, you may want to look things a little bit and step back to understand that, is there a way I can decrease the current utilization? So we do provide a cold, hot, warm kind of a temperature zoning on your file system to help you understand which files are not being accessed or not being modified for a very long time. So you can just directly click on this. It will immediately highlight you those specific files where they are located, not being modified, not being accessed for more than a year. That would help you at least to reduce the cost, save some servers addition cost as well, improve the better stability on the RPC front, or creating some kind of a bottlenecks due to increased number of blocks in the HDFS. So you can apply any of such custom filters here to get your answers. And the best part is there is a REST API response available that you can query and create your own dashboard and visualizations from here as well. Coming from the storage, understanding as we provide the file explorer view, the second key things that usually kicks in when we are running an applications in the system is the compute part. So as you know, from a Hadoop ecosystem, Yarn is a major contributor in terms of running things and negotiating with the resources moreover. So here we provide you a complete capacity dashboard panel to help you understand the kind of applications you are running, what kind of an applications even you are running. And let's say if I do last 7 days of analysis, below dashboard will give you immediate response on what 66% of my applications are Spark, 74% of these applications are coming in from finance queue. And I can easily see more on the duration of these jobs. Let's say what categories of these jobs are usually my duration corresponds to. So we get this dynamic categorization itself. So you can immediately identify if there are any outliers, any long running jobs, such specific jobs which is consuming more amount of resources. So you'll be able to view this in this metrics distribution. Along with this, we also highlight the live queue distribution. So in case if you're running or submitting apps in your queue, you will be able to view their current resource availability in it. In case you are always in a confused mind that how much resources should I allocate to this queue, how it should be adjusted. So we do provide a under overutilization kind of a dashboards as well in order to better understand your current capacity utilization by users. So here, as you can see, the queue and the resource utilization at queue level, at the user level itself. So which user is consuming most amount of memory or cores in the system, you can come to this dashboard and view this itself. And you can anyways apply a filter here on the queue level and you'll be able to see metrics with respect to that queue. So coming from the queue utilization, the applications that is being submitted. So we provide a live application explorer view that the current live running applications in the system, what is their current progress, as well as the apps that have been completed, what is their current or what was their utilization when they were running. So we do provide a complete snapshot summary of these apps when they were running. So you get to see moreover all the details, how much resources they consumed at an application level, number of containers they took in order to launch, the total node managers on which these containers were launched by these applications. So all those details, summary view, along with several other columns that you can add in order to view things here. Along with this, you also get to see more insights about when these apps were running. Maybe you want to kind of know that when this app was running, was there any alert or was there any incident that was raised? So in some of the cases, you may be restarting, let's say, a node manager. Now, restarting a node manager on which the application is running may cause the container to go down, to go in a kill state. So in these kind of scenarios, it is really important to know that when the app was running, it could have cases that some of the available components were not there. So you can immediately see on that apps, was there any event that any incident was raised? You can also view that which node manager was down and whether it is still down or that alert has now cleared. So you'll be able to see when this particular issue occurred and when it got fixed. So this will let you know from the time when the application got started, what were the incidents that were raised in the system that could have impacted the performance of the app as well. Along with this, you also get to see the variance information. So the same app, when you're triggering over the period of time, so you may be wondering about its performance from first day of the week to the last day of the week or a month, maybe, that whether the performance have degraded or improved. So you may want to know these kind of answers. So we provide you a variance chart here. And from this, you will be able to view its past run comparisons of this app as well, that an average, how much time or what is the average duration, or what things have changed over the time, or what counters have changed when this app was running, comparing it to the previous runs. Along with this, we also provide you the queue utilization. So you may have heard from your administration team or developers complaining, engineering team complaining that we don't get enough resources when you are running app. And you don't get to kind of signify that what was happening at that time, how much queue utilization was there. So you can anyway see from here, then when the app got started and when it got finished, what was the resource utilization of the queue, whether it had available resources or not, if there were any concurrency issues. So as you can see, this chart and dashboard will show you if there were any concurrent apps running at the same time when this app was submitted. And also it will show you that per node manager level, if containers were available or not. From this, you will also be able to kind of redirect to the logs. Let's say if you want to kind of check some of the things, what was the application logs, what any errors or any warnings was reported. So you can click on that log icon and you will come to this log search view in order to get more details, in order to apply any kind of a log label here and view it in more context. So you'll be able to see if there is any warning being raised or any error messages being traced. So all those things you can easily track and you'll be able to come to this log search page from here directly. Along with this, you can click on any one of these applications and it will redirect you to the details page of it. So let's say if you're deep diving some troubleshooting some issues from that application, and you want to understand the complete summary and a picture about that what is causing the failure of this app, or what is causing the usual scenarios, and whether this was the same occurrences in its previous thread. So in details page, Pulse has the ability to kind of highlight what was the previous run counters, what was the value, how much time it took, whether these app was succeeded or it failed. So as you can see, the same app was succeeding in its previous attempts and it failed on certain specific events as well. So here you can see more query statement, the compiler starts and plan, even the details about that how much time it spent in just in the accepted state. So the major reason, as you can see, this app was failed or maybe got killed. So it was stuck in an accepted state for a very long time. So almost from a particular date, it was stuck in that accepted state. And you can also see more information around the query breakdown, that how much time it took in order to just complete. But since this app was in accepted state for a very long time, so it got failed here. Along with this, you also get to see the complete plan interactive view in order to know that which stage of this query is performing really bad, or it is having a scope of optimization where maybe vectorization is not getting enabled due to some operators being used. So all those cases being highlighted here. And the best case that you can anytime compare this same app to its previous runs. So if you want to compare the same application or different events of this application to a particular timestamp, so you'll be able to kind of do any metric comparisons, that how much amount of changes have happened. Maybe the app is running longer period due to increase in the scan on the HDFS, or writing some data back at the HDFS has increased. So all those differentiating benchmarking that you usually do manually as of now today, you don't need to worry about, and it's being captured and collected directly in Pulse. So you can anytime come here, you will be able to kind of do config-based comparisons. And you can also do a interactive plan-based or DAG-based comparisons as well. In some of the cases, what we have seen in a couple of customers and that they don't change the query, nothing gets changed. Even sometimes data remains same, but the stats and the planner that gets created from the CBO engine gets changed over the time. So as you can see, it creates a different plan altogether. So in order to prove that things have gone changed, or the plan has understood now or created a different altogether, a different compiler plan itself and prepared a different physical plan. So you'll be able to do direct DAG-based comparisons in this canonical view. Coming to this, similarly for a case query-based breakdown, we do have more Spark-based or application view breakdown as well. You don't need to kind of worry about that. If particular application was failed or launched, now you need to go back to the logs to check what went wrong. In the details view itself, you'll be able to get the summary, what happened to that particular application, what went wrong, any kind of an error or trace that got collected. So you can click on the logs here and you will be able to see more details and summary about this application. Along with this, you'll also be able to see more details about the Spark jobs being submitted by the users. So in case one of the application that you submit, so you'll be able to see the complete stats and summary about it. How much time it took, what were the inefficient stages in that Spark job, any scheduling delay, comparing it with the previous runs, even comparing the counters, that what has changed the core or the configuration level, if you have changed anything which is causing now the app to go down or slows down or run faster than its previous attempts. And here we also provide the recommendations. So you can see the current value that was associated with this Spark job and the recommendations around it, that how much resources if you could have added or you could have allocated to this configuration, you could have optimized it, that could have made the job to run more faster than its current time. So we give you a scope of optimization even for a successful jobs, that where you can improve the performance of the applications, and also highlighting some of the inefficient stages pertaining to even a successful job around the things that could be a cause, or later down the line, it could cause an issue in the system. So majorly we try to capture any small task or runtime skewness issues where single task is running for a very long time. So we do capture the complete task analysis summary that which particular event or what kind of an issue could have caused the single last task running for a very long time compared to its previous ones. Along with this, you also get to see the live status summary, that whatever you have allocated in terms of resources, how much is it being actually getting utilized, which is a really critical thing in deciding whether the resource allocation that is being done currently, is it getting fully utilized or is it getting wasted, or you're just consuming the resources, but they are sitting idle. So we get to provide you complete reporting on the efficiency statistics, simulation. So as you can see, we were earlier recommending it that you could increase the executor count to 5. That would definitely decrease your runtime of the job. So here, as you can see, if you keep on running with one executor, you will get a performance of around 13 minutes for this job. But there is a scope of increasing the executor count to bring in more parallelism here where it's possible. And here it will also highlight you the cluster utilization when you are increasing the executor, but it is decreasing the runtime of your job, which is helping you, but along with the cost that is getting involved. So you get to see the balance of bringing in this recommendation in terms of your SLAs and the cost that it comes around, and even the locality usages. So with the current one core, it is getting utilized completely, almost 90%. So you get to see a complete breakdown of your current utilization, how much it is happening, and the scope of improvement in the particular job. So with this on the yarn front, any application explorer, you will be also able to see the same app, same queries in the listing framework as well on the jobs. So you don't need to go on to details. You will be able to see individual days queries, how much, which query is running, or which were the top 10 queries in the system that were taking most amount of time, or that were scanning a lot of HDFS records, any recommendations that is being generated, which server they were being triggered by, or which Hive server 2 was responsible for executing this particular query. So all those details gets captured from this listing and gets added from here. And you can anytime click on the details and you'll be able to redirect to the major page here. Along with this, we also have other components offering in Apache open source, more on the HBase, Kafka dashboarding in terms of going over, understanding that how your topics distribution looks like, if there are any inefficient partitions or your strategy is not working out well, how your growth trend is looking like. So you can see all those information moreover, and some of the practices that you're not following in the standard Kafka storage strategies, and you're falling into a zone where you keep on increasing and adding data, but not creating the right partitioning strategy. So you'll be able to kind of notice from directly from these views itself. Along with this, with the query and with the tables that is being stored on the Spark or whatever the tables metastore objects that they are kind of using it, you'll be also able to see Database Explorer. So the tables that is being stored or tables that you're creating in the system, you'll be able to get the analysis around it. So that not at the query level, you'll still be able to see more information that how is the storage strategy on the table front looks like. So for example, if we go into one of the particular table, you'll be able to see more details about how is the partition storage looks like, or partition strategy is there for that particular table. So in some of the cases, if the underlying partition strategy is not calculated in a better way, you may see that some of the partitions, when it's doing a scan, they are running faster. And for the ones where the size of the partitions is on the higher side, the query is taking more time to complete. So those kinds of a table storage to query statement level, all those recommendations and more of an analysis, you get to see from the Pulse here on the Database Explorer. And similar to this, we also create analytics reporting around it in order to know which tables are now not being used that often. What are your top 10 tables, top tables with highest number of size, highest small files in it, or you're creating a lot of small or lot of number of nested partitioning, which is exhausting the Hive server when you're reading or writing it back. Similar to the data temperature at file level, we also highlight that which tables in the system are not being accessed or not being modified for a very long time. So you'll be able to see the same kind of a table temperature view here as well in the reporting. Along with this, all the apps, anything that we are running, it is majorly responsible on how the host or the node managers on which these on the host they are hosted. So it's really very important to know that how at the infra level things are working out. So we do provide a node level statistics around as well, and we provide a deep dive information in a detailed view to understand from an OS telemetry how things looks like. So for example, all this service mapping you will be able to see, and you will be able to view that. Let's say if it is a Kafka service, on which nodes are this Kafka service running on, and you can also click on the node managers. So in some of the cases where node managers are taking time to launch containers, or they're already exhausted with some of the other additional requests, so you'll be able to immediately view based on the load which particular node manager is having the how much load metric over the time. So what is the value, and you'll be able to click over it and see better information around it, that what kind of an applications are being hosted on that same node, whether it is already occupied to run multiple services. From the complete OS summary view, how much is the CPU or system summary view, how much is the memory utilization looks like. If it is getting disk utilization to reach to 90 or so percentages, you'll be able to view the threshold or any kind of a throughput benchmarking you're doing on that particular host from an IO or a network perspective. So those stats gets collected. And the best part is that you can go back and check exactly that in case one of the node went down due to some CPU limitations on or the service that was running on them, it was exhausting the resources. So you'll be able to view and capture it directly from here. Along with this, anything that we are hosting on that server related to Yarn, Kafka, you'll be able to view a complete summary of things or the services you are running on that host. As well as the important part from all the JVM services that we are running is the GC utilization. So all the services that we are hosting over there, how is the GC events are occurring out, or how, is it spending more amount of time is just for specific service to complete the garbage cleanup. So you'll be able to view those information as well. And the best part is that along with this same host, you are always wondering to check any kind of an error messages or fatal logs in it. So you don't need to go or click on any other page. We do collect and summarize all these things over here itself, and you'll be able to view any kind of a log messages printed in last hour, or let's say in last 24 hours. So you'll be able to view all those summary information here itself in this. Coming from nodes, the most important for any Hadoop administration or at the engineering level is to have a view, have a centralized view, so that you don't need to do any SSH in order to look into things, in order to kind of trace back any kind of application errors. All you could do is come onto this log search page. You will be able to click on, I'm just clicking on one of the errors here. I'll be able to see which services are reporting the errors. You will be able to see the dashboard, that which service is reporting the highest number of error events in the logs. And you'll be able to see the complete trace of it. And let's say if you want to kind of search for a particular message in it, timeout or error, so you'll be able to kind of apply this such kind of a custom filters in it. You'll be able to highlight those information as well. You can group this information at a host level, so that you don't want to kind of know that these error messages are coming from which host. So you can group it by host, and you'll be able to see all this information from here. And along with this, we also capture the audit level statistics on the HDFS or Hive audit logs. So all the log search view, you get a centralized feature here in order to not log into the sessions and keep on searching for a particular message in the logs history. With this, we provide a better option that any messages or something that you're trying to, let's say, look into the logs, we give you an option that through this log, you can create a custom alerts as well. So along with this alerts feature that we offer as part of the additional utilities with Pulse, you will be able to create custom alerts in the system itself. So for example, all this alerts that is part of in this installation, we do provide 100 plus out of the box alerts here. And in case if you are focused on some monitoring some specific metrics, or you are in search for a specific breach of an incident, you can create your own alerts. And as I was saying, you can create alerts on logs as well. If you're trying to search for a particular message, and you hit that particular message in a multiple events, you will be getting an incident and a notification as well. So let's look into one of the alerts. Let's say CPU utilization alert. So in this alert, you'll be able to see the condition that is created and at the host level on which this condition would be mapped to. So you'll be able to know that which host the CPU utilization has reached to 90 or 80%. You'll also be able to see that all the threshold that you can configure in order to avoid spamming, avoid creating unnecessary alerts. So we make sure that you get a complete alert threshold features control. So you can keep on checking the condition until it reaching a tolerance factor. So you can control it from here. And you get numerous notification medium channels, email, Slack, ServiceNow. Create an incident as soon as it gets logged, and you can log it in your ServiceNow channels. And as you can see, this is one of the service that is getting created in here. It's created a notification. It tells me that node manager URL, there was an endpoint check alert, and it shows me that this is the URL that it was trying to monitor, and it wasn't getting any response from that, which host this particular alert was raised from. So all those details gets captured in the simple notification message itself. And along with this, we also provide a way that you can take an action. So when an alert gets raised, you can also create an action on top of it to make sure that it doesn't create unnecessary outages or severity one like a situations. So you get the detection, you get the monitoring, you get moreover the feature to handle those particular situation as well, or mitigate or auto heal those kinds of problems itself, which gets created in the here. So for example, very common thing, let's say you are running a long running queries and you may want to kill those applications or kill those long running queries. So as soon as the alert gets created, an action can be associated with them. Or let's say you want to restart some of the common recurrent service that you haven't found a workaround yet, but just for a mitigation, you are currently trying to restart something. So you can apply these kinds of an auto action playbooks itself over here. And you can specify description and the message alert summary that you want to know when this kind of an alert gets raised. And all this information gets tracked for later purposes to understand that what kind of incidents are frequently being raised in the system, or what kind of issues are generally occurring, when they occurred, when it was raised, when it got cleared. All these things get tracked in the alerts itself. Coming to the more on the automation part, in order, which is very critical and helpful for a lot of our administration and developers who basically will then code and bring into the production environment. They may want to run some reporting events. So we do provide a lot of out-of-the-box playbooks that you can use. So one of them, such as I was mentioning, killing a long-running case query. So you can select any arguments. You can create your own playbooks and plug it in here as well. But for example, in this playbook, you can specify the time which you want to filter those specific apps, and you want to confirm whether you want to kill them. Any LLAP queue, we want to skip it because it has long running queries in it and it's a long running application. So we don't want to kill any Hive containers over there. You can specify the host in which you want to execute these playbooks and the user through which you want to run that action itself. And along with this, the best is that you get to know the schedule option as well. So you can schedule these playbooks to run independent of alerts, independent of any other panels here. So you can schedule any kind of a cron jobs that you're currently doing in system, and you can directly view and create these actions over here. So you can also see its past executions, that when it started, when it completed, as well as more logs around it, that when it was, what was the logging events or any kind of logs, or any, if it failed, then what was the reason for its failure. So anything that you're scheduling, so you'll be able to view the complete log messages as well. So this brings to moreover the end of the demonstration. So I'll give you back, Loretta, for any questions that someone has, so we can answer that.
Thanks, Shubham. Yeah, I'll provide a quick recap. I'll go ahead and share my screen now.
Sure.
So thank you, Shubham. Clearly, we've got many capabilities within the platform. We've only had a chance to really touch on a few of the key technologies. These are some of the major components that we support, and we have similar recommendations and analytics and things to help you both be more efficient, to reduce your cost, ensure reliability, reduce troubleshooting time, and all those sorts of things. So to recap, our data observability platform really is designed to help eliminate blind spots, to save you time, to improve performance and reliability, to improve efficiency and lower infrastructure costs. Some of our customers have lowered their infrastructure by 50%. Moreover, our support offerings help you mitigate risk, lower the total cost of ownership, and in many cases, most importantly, give you the flexibility to pursue the strategy of your choice on your timetable when it comes to continuing with your existing platform or migrating to alternatives. So we saved a little bit of time here at the end for some Q&A. Loretta, did we get any questions that we should answer for the audience?
Oh, yeah, we do have a few questions. I'll go through them. And then if you do have any additional questions, feel free to put them in the Q&A and we can add them. But let me get to the first question here. And that is, does Acceldata support include patch support as well as open source support?
So yeah, let me take that question. Yes, the Acceldata support offers the patch support for available patches available in the open source community. So we do provide as part of our offering.
Great. Mark, do you have anything to add, or that we're good there?
Yeah, we would love to work with you to understand exactly what your environment is. In many cases, we've been able to provide patches faster than Cloudera, or to be able to create new patches at an accelerated rate. So ensuring that customers' environments are secure, up to date, performant, et cetera, is one of the key parts of our offering.
Great. Okay. The next question is, does the support include data migration planning effort as well?
Yeah, so in some of the special cases where our team needs our expertise and needs assistance in order to better plan some of the key production clusters when they want to migrate into our Hadoop platforms. So we basically do provide them and help them from a professional services.
Yeah, and I would just add that the platform itself can help with migrations as well. So for many organizations, they want to make sure that they've checked that everything is running equivalently when they move to the cloud, for example. Say if they move their Spark jobs to Databricks, they'd want to make sure that the performance of their jobs running on premise are the same or better when they run them in Databricks. They want to make sure that the quality of the data matches, that all the data got there, that nothing was corrupted, no data decimal points were dropped, and that sort of thing. And we can do both of those. So we can benchmark performance both on the Hadoop environment and on other platforms such as Databricks and others. And we can also validate the data that it matches with our data reconciliation capabilities. So regardless of whether you're working with an SI, you're doing it yourself, regardless of the tools that you're using, we can provide third-party independent checks to validate performance and quality for those migrations, which is often one of the most difficult, time-consuming, expensive, and important aspects of a migration. The other thing is that when you do move to the cloud, there's other challenges you may encounter, such as runaway costs, because it's a consumption-based model. And so many organizations that are new to the cloud, especially when they're moving large environments, they get surprised with large bills, and we can help with both understanding the efficiency of that, being able to predict what those costs are, and so forth. So I would say, regardless of whether you're continuing on with Hadoop or you're looking to migrate, we can help you around all of that strategy.
Great. All right. So we do have a couple other questions that came in. One of them is, does Acceldata support Kubernetes deployment as well?
Yes. So we have multiple products on data platform and data observability. So Pulse, we do provide a support on some of your components hosted on the Kubernetes, such as maybe you're running Spark or Kubernetes, Spark or Kafka on Kubernetes environments. So we do provide observability to those services, even though they are hosted on a Kubernetes environments. And we are having in our upcoming releases coming up with deployment model for Kubernetes-based support as well. Yeah.
Great. And one more question. Does Acceldata support scaling?
Yes. So in terms of scaling, I hope it's being questioned more from the platform. So do we help in kind of giving you the right insights about whether we can scale further, or what is the current things look like from an existing scaling point of view? So for example, if you're increasing the storage, or if you're increasing the clusters, resizing it to increase more compute or add more storages. So you may want to check in that how things looks like in a current base scenarios. And we do provide a forecasting. We do provide an analysis that after 30 days or 60 days, how things will be looking like. So to help you make better decisions during the capacity planning. So there, yeah.
Yeah, and there's even, I think, some other aspects of when you're looking at scale. So certainly we can provide insights to help you with your capacity planning, forecasting, and so forth. We can get down to the job level and tell you where the specific bottlenecks are within a specific job or query, so that you can scale that job or query. And some of that was demonstrated by you, Shubham, when you looked at the simulator and those sorts of things. And then the other aspect is, how does our platform scale? So our platform is designed with very lightweight agents, so that as we apply observability to your large environments, you're not going to take a large performance hit in terms of being able to do that observability. In fact, I believe it's very low percentages of compute that are required. And that helps both with your on-premise infrastructure as well as with costs in the cloud. But we do run our platform in a distributed fashion. All of our data quality rules, for example, can run on Spark in multiple environments. So it can be, you can address data performance and data quality issues on petabyte scale environments, something that is a big differentiator for us in the market.
Great. So those are the questions that we have. If anybody would like to ask one more question, we have a couple minutes. Feel free to put something in the Q&A. We'll just give you a few minutes to do that, and I'll watch the Q&A. Here's one that's coming in. Does Acceldata support standalone cluster?
Yes. So in case the question is more around some clusters which is not part of any distributions, or they are standalone services such as Kafka or Spark standalone clusters. So we do provide all the integration and observability support for such clusters as well. And if you are having your own open source distributions, or you're directly creating and launching the clusters from open source projects, so we do provide the integrations with those clusters. So it doesn't have any dependency on any vendor or any specific distributions. So we do provide Spark, Kafka standalone clusters integration, and as well as such as if you have Confluent Kafka clusters, so we do provide observability with Pulse, with Torch on them, on those clusters.
Great. All right. Well, yeah, thanks so much, Mark and Shubham, for your expertise today. Thanks so much for everyone who attended the webinar. You can come to our website and sign up for a free trial. And in addition, as a thank you for all of you that attended, we will be sending you a $50 Amazon gift card. So expect to see that via email in the next couple of days. So again, thanks very much for your time. We appreciate it, and we'll be in touch. And if we missed any of your questions, or if you would like to email us with any of your questions, feel free to do so, and we'll get back to you. Again, thanks a lot, everybody, and have a great day. Appreciate your time. Bye-bye.